Hello, everyone, and thank you for joining us today for our LA Tech Days event for Trillion Quality Systems. I am Walter Schnapp. I'm here with my colleague, Jerem Hatch, who is one of our senior applications engineers for the Western region. Really excited to talk to everyone today. Appreciate everyone who was able to join on the webinar and also for everybody who was able to join in person. The discussion should be pretty interesting today. So the main focus that we're going to talk about is going to be over the DIC, digital image correlation, optical strain measurements, a little bit about our work at Trillion in that field, and then we'll also get into the discussion as far as the release of the ARAMIS one. This is a brand new sensor from ZEISS that has just arrived in the United States, and yeah, we're very excited to talk to you guys about it. So at the end of the presentation, we'll have a Q&A, and we can get into everybody's specific questions about the sensor and anything else we covered in the earlier talks. So before I get into all of the details with the rest of the presentation, let's just give a little quick background about Trillion in general, just so you know who we are for those who don't already know. So Trillion Quality Systems was founded in 1998 by our founder and president, John Tyson. So our headquarters is based in King of Prussia in the Philadelphia area, but we have offices all over the country, as you see here on this map. We also do work in Canada as well. So we are the North American reseller for ZEISS metrology products. So these are just some of the example customers and some of the example applications that we've done over the course of working in this space. So this is not by any means all of our customers, but just gives you an idea. So one of the wonderful things about working in this area and taking optical measurements is that it's not limited by any kind of application or anything like that. Basically, the mindset that we have is if you can see it, you can measure it. So today's discussion is going to be very DIC focused, just being that we're covering the ARAMIS 1 release, but we do work in several other areas as far as our partnership with ZEISS. So Argus is our forming analysis tool. You see this used a lot in the automakers industry for sheet metal forming analysis. TriTop is our optical CMM tool. Both of those use a DSLR camera for capturing the images. ZEISS CT, we do not work as much in the X-ray and the CT scanning, but ZEISS is very involved in that. As far as Trillion goes, we are very involved in the different types of scanning, the blue light scanning, as well as others. So it's quite a lot of tools at our disposal. So it's quite interesting. If everyone has any questions about any of that, feel free to reach out to us. So our team, we work in all different areas. As far as the main focus, though, it's going to be system sales for ZEISS metrology, but also engineering services, so performing measurements on behalf of our customers and providing technical expertise and consultation. And then also, obviously, training our users in how to do measurements and how to use their systems effectively. All right, so let's just spend a brief time going over what ARAMIS optical strain is and what DIC is as a topic. So in terms of the engineering information that we're trying to capture in many of these applications, displacements, vibrations, strains, the traditional methods for capturing that is single point mechanical solutions. So most of us are familiar with these. So LVDTs, laser trackers, string pots for displacements, the others for strains and vibrations. We see strain gauges a lot, extensometers, flip gauges. So all of these tools are single point mechanical solutions. They are reliable in certain contexts. They do work fairly well in certain ways. They are the standard for a lot of different things. But however, they only provide a single point of data. For every single tool that you have, you only have one point of data. And that assumes that it was applied correctly. And that's another big point. So engineering, when we are using finite element models increasingly, we want to validate those with robust data from the testing side. And so in order to do that, you have to employ either a lot of these single point mechanical solutions, or you can use the solution that Trillion is working on, which is the full field non-contact solutions related to optical measurements. So instead of getting a single point of data, you are having thousands of points of data for an entire surface. That's kind of how we view the discipline, and the benefits of doing DIC is instead of seeing a couple of points, you see the entire surface. It's the real thing. It's not a model. It's reality. You're measuring reality, truly. So there's a couple different ways of capturing the data that we're looking for. The main principles that are involved is to use two cameras or point on a surface, very much akin to the way that a human eye and the brain, human eye system, and the brain works. So with that, we have the stereo cameras, which you can see here. There's the surface. So the way that the data is captured and is recognized by the software is with two different ways. So the first way is with target dots. So in this video you see here, the runner is going through the motions. On the outside of the blade is the target dots. So we applied those prior to the test, obviously, and then we also have some located on the brace. So you're basically seeing the full displacement vectors of the blade. Now, also on this is applied rigid body motion compensation. So that basically is allowing you to see just the motion on the blade itself, not the global motion of the runner and everything else that's happening in the. So the other way of capturing strain information is via the stochastic pattern. So this is a real typical dog bone test sample. It's being loaded up in the tensile test machine. It's had the stochastic pattern applied to the outside, obviously. So as it's being loaded, you can see the simulation overlay on the software. So obviously the red is where the strain concentrations are highest. This is a metallic sample, so you can see the Lüders bands that are forming at the top here. That's a crystalline level response that you're seeing. That's not something that you can capture with a strain gauge or a clip gauge or an extensometer. So pretty interesting stuff. But this is a real typical example of what strain data looks like and displacement data looks like in the Correlate software. And obviously there's a gajillion manipulations you can make with that. So we'll get into that later. So these are just some of the various benefits that you get out of using DIC as a discipline and testing methodology. In terms of the work that we've done at Trillium, like I mentioned, being that it's application in size agnostic, which is absolutely lovely for us. We get to work in all different workspaces. These are just some of the different examples of tests that we've done in the past. This one at NASA Langley, I believe, was a helicopter displacement measurement for the fuselage, extremely large measuring volume, as you see, but then we also have really small ones, for example, for this hex head bolt being turned by the reg. So there is a video that we want to show you from ZEISS, but before we do that, we wanted to get into some of the key features we were especially impressed by on the ARAMIS 1. So truly mobile is definitely the right phrase for this. Or the cases that it comes in are very, very easy to roll around. The main sensor case is about the size of a suitcase, which I'll show you here in a second. The controller itself comes in its own, which is very nice, and we'll demonstrate what that looks like later. But this is the inside of the case itself for the sensor. So we have the sensor cable, the camera, one of the lenses pulled out just so you can see what that looks like, and then one on the actual sensor itself. Then this is the just some calibration equipment, and then you have the stand for the calibration object. Really nice to be able to have all of this contained in one case. So the setup is extremely fast. I'm going to demonstrate what the controller setup looks like, but it's basically just a couple of cords for plug-in of the hardware, and then you're basically ready to get started into calibration and setup of the rest of the sensor. Here's a image of the calibration object and its holder. So this is the larger of the two. So this is in the top of the sensor case. So the other, it has a smaller one, it's about a quarter of this size, but it fits all within the main sensor case, which is super nice. The configuration is just normal adjustable base camera bar. So the calibration is very, very robust. We did move the sensor around quite a lot during the course of testing. With the Aramis one, it remained in calibration throughout the whole time. We did have also some temperature swings, but calibration, yes, held the entire time, and we were really pleased to see that. So the new lenses are the C-mount type, and they are very high quality. ZEISS, of course, knows quite a little bit about making good quality lenses. These are the fixed focus and focal length type, which is really nice because there's no more need to use a special tool to adjust the or to tighten and loosen the focuser knob. So it's all just thumb screws now. Very nice. And there's only 2 sets of lenses that are used on the Aramis one. So simplicity is definitely one of its strengths. One thing that we really liked about the camera bar is that it has this strain relief feature lock, which locks the camera cables in place. So when you are adjusting the width of the cameras, as you would in during regular setup or changing measuring volumes, you can push the camera cables through the little channels here and then lock them in place. So it gives you excellent strain relief during testing, and then allows you to have that quick adjust feature, which is very nice. We really like that. We have the new LED system from ZEISS. So this is a brand new light feature that we've been talking about at length. So this would be in place of the normal 10 and 30 degree lights that would come in the wrong configuration of the magic arms. The magic arms are still going to be included in configurations, but in the one that we are testing, we did not have that set up. So just a couple of features of the light itself. We have different options as far as polarizers and diffusers. There is an integrated laser pointer, which I'll show you later. There are different levels of power modes. So you have a huge amount of adjustability here compared to the old configuration. So we really like this. Quite often in testing, you have, you're kind of at the limit of what the testing environment is in some instances. So having this adjustability is really good. And a couple more details on the lighting control system. So all of the side of the light, like you see here, it has a cooling fan to keep everything going good. So you can turn this on independently of the controller or of the computer. This is great because as long as it has power, you're going to be able to turn the lights on, which is really nice. A little bit more information about the polarizer system. We can go into this later in more detail. This is basically just allows you to have all different settings as far as to reduce glare and get the best conditions for setting up your test. The diffuser and polarizers all fit directly on the face of the light itself, so there's just one for each. So instead of having a pair of everything, you just have the one. So this just gives you a sense of what it looks like from behind. This is a dual light configuration setup. This is the setup most akin to the one that we used in testing the Aramis one. So just the single light, but then you also have the dual light configuration. And then we also will be offering these with the magic arms like you saw in the older style lights. So in addition to some of these other features, ZEISS will be releasing a new model where you will be able to use the Aramis one as either a 3D sensor or as a 2D sensor. As in, it will split up the camera parent to give you two 2D sensors. So now that that's covered, we'll introduce the short video from ZEISS. So getting into the discussion of the Aramis One. So one thing that is very important to note about the Aramis One is that it's a 50 hertz frame rate at full res. So that is definitely something that a good amount of speed for a quasi-static sensor of this type, being the 5 megapixel. Camera resolution definitely helps with the speed. So for with the more dynamic measurements, definitely a benefit. With the Aramis One is the controller. So with all of our sensors now comes the new controller, which is really an outstanding tool. One of the benefits of doing this is that in addition to being able to record all of your load signals from other types of testing machines like load cells or whatever else you're doing, and you have various other signal inputs. But in addition to that, you can also do concurrent measurements with 2 Aramis sensors via just one controller, which is a huge benefit. So it is something where if you are trying to do multiple views on a test article at the same time, the Aramis One is a really excellent addition to your current sensor lineup. So say if you already have an adjustable base Aramis sensor, having an Aramis One as a backup additional sensor is definitely something to consider, because then you would be able to add that entirely additional view for a much lower price point, which I'll get into later. And that is obviously one of the big draws of the Aramis One, is that it is a lot less expensive than the adjustable bases from the larger resolution sensors. But that's by no means the main point, but it is something to consider, especially for those labs that are concerned about budget. One thing we were really delighted by as far as the sensor or just the overall package for the Aramis One was just the compactness and just how easy it was to move around. So I'll show in the video later as far as the actual setup and what it looks like. So in terms of the accessories, you have the normal mounting systems, tripod, and then the boba stands. ZEISS Correlate Pro and Pro Line are both options for the software package. This will use its own sensor driver, Aramis 5M. So 12M and the other various sensor drivers that work for the other Aramis sensors will not work on the Aramis One, unfortunately. So it does require its own, and it does require UV in 2025. So just things to note. But it does have the capability of using touch probes, which we offer as well. And then the sensor is available to get with or without a ZEISS laptop. So that's typically something that we would really discourage in the past, just because of the necessity of the setup for the computer for DIC specifically. But now having that option of being able to use your own laptop is definitely something that will be a cost savings for our customers. That's something they're concerned about. All right, so we'll get into the setup of the sensor and using the software now. The new controller box opens like this. Lid comes off. There's a setting for your laptop, and then it has these holders with Velcro. Really love these panels. Move this, controllers inside. Same in reverse. You have all of your access ports. This is a roller. So taking this to the airport and moving it from site to site is very easy. We really appreciate the compactness of the setup and how easy it is to move around. Everything just snaps back in place like this. I have to note ZEISS really does a good job as far as the spline of the mounting setups. All set. All right. So a big thanks to everyone who was able to attend our webinar today. We really appreciate it. Hopefully you found it informative. There is quite a lot of excitement here around the Aramis One, like I've kind of talked about. So please reach out to us if you have any questions or if you'd like to learn more about this as a topic. You're going to see it increasingly out there in the field. So we're looking forward to getting some new papers and results published from the testing that's out there. So we'll look forward to publishing that and talking to you further about this in the future. All right, thanks. If everybody can hear me okay still, I just wanted to say thanks again, and we can begin the Q&A portion. And it looks like we already have quite a few questions coming in. So I'm here again with Jerem, and we have some of our other users and interested attendees at the in-person training. So let's see, get going on these questions. So, Jerem, the first one looks like, how does the Aramis One fit into the larger optical testing roadmap or lab strategy? I think that, in terms of a lot of our users who are looking into the Aramis One, if you're a first-time user getting into DIC and you've never done this before, it's definitely a situation where an Aramis One is definitely a really good candidate for a first-time DIC user. It's a situation where the simplicity is really there, the mobility, the adaptability is definitely there. But additionally, you get started off using the sensor. It has, because of ZEISS's organization and the way that they have everything set up, getting upgraded to a larger sensor later if you need it for different testing. Using another sensor for concurrent measurements. All of these things are really well established in the ZEISS framework. So they do a really good job of supporting our users who want to get into different types of testing later on, or, just whatever it is that they're doing. So, yeah. And yeah, that kind of also goes into the next question. What's that? Oh, sorry, you can see us now. Excuse us. That kind of goes into the next question. Can we upgrade later if we want to enable advanced analysis or parametric workflows? And that is definitely the case. The ZEISS software that's typically used for the Aramis One, you can either use it as a basic correlate package or with the Correlate Pro line package, which will give you those advanced parametric workflows and all the stuff that goes into that. So yeah, it's a very customizable package. And we were kind of talking about earlier as another benefit of working with Trillian is we have a full software developers that we work with as part of our organization. So custom workflows, doing more of the advanced scripting, everything, all of the coding is via Python. So it's very customizable on that side of things. Any questions from the guys online? Let's see here. And then,
well, you can take a look in the publish section. There's a couple of questions that are in there.
Okay, got it. Thanks. Sorry. Okay. Oh, yeah. Just saw this question from Kurt Horton. Hi, Kurt. So we, as far as costing, so for a basic Aramis One package, and obviously it's a situation where there's a lot of variability in what you can get in a package, but we're targeting probably around 60,000 to 70,000 for a basic package. Like I said, that depends on kind of what goes into it. But compared to some of the higher resolution sensors, it's going to be a significantly less expensive. And is the Aramis One compatible with other ZEISS systems or modules? Yes, it is. As far as like the way that you would use the other modules, can you kind of give us more of like an overview of what that would look like? All of it's done with the ZEISS quality suite. So I guess it would depend kind of on what technology they would be using.
Yeah, I mean, the same software.
Right.
And then you can pull these systems together, but I can't remember if you can do it.
Yes, you can. That's another thing that we want to mention is that the sensor is one that can, the new ARAMIS controller will allow you to run concurrent measurements. I think I said that earlier, but yeah, you'll be able to do concurrent measurements with different systems, or sorry, different ARAMIS systems with the single controller.
Yeah, so you could pair this with a 12 megapixel system,
right?
Or you could upgrade everything. You get two 12, two 12 megapixels. So it's very flexible in that sense. Different system types.
And what kind of accuracy and resolution can we expect from the ARAMIS one?
So we're probably talking about the same accuracy levels as the 12M in terms of strain analysis. So typically we like to talk about somewhere around 150 to 100 microstrain for strain analyses, and then the displacement analysis again is mostly dependent on resolution. So instead of having our typical 12 megapixel, we're now at 5 megapixels. So you're losing a little bit on the accuracy of displacement analyses with that lower resolution, but not by much. We could probably look at the spec sheet for that. We just pull up the resolution here. Yeah, so 2472 versus our 4096. Yeah, depending on whatever field of view you're looking at. But yeah, in our case, I mean, we can look at the sizes they have available. So let's just give it just some rough numbers here really quick, but 50 millimeters to 2752 or 2472, sorry. So, roughly, what is that, 50 millimeters, we're looking at like 0.7 microns displacement sensitivity, roughly.
0.7 microns, you said?
Yeah, and then 2472. And then the largest field of view, probably about 7 microns of accuracy and displacement tracking. So, still pretty good in terms of smart analysis there.
And then the next question we had was, how easy is it to switch between lenses? I think we can both agree it's pretty easy. The standard package comes with 12 millimeters and 25 millimeter lenses. Basically with this, you don't have to use a special tool to remove and change those. It's basically in some of the other ZEISS sensors, you would need to use an Allen tool to adjust the focuser. So now it's just going to be thumb screws, which makes it very easy. And then just basically the unthreading them from the camera itself.
And then if we could go back, there's another question here
about
linear versus circular polarizer. So this is a really, really important question for this. I'm actually going to share my screen, I think. And see if that works. Yeah, perfect. So there's just a couple of slides here on linear versus circular polarizer. So this is the first ARAMIS system to be able to give you both options, and they both come with the same mount. So it's basically a reversible polarizer filter that you place on the singular light that will swap between being a linear polarizer and a circular. So you kind of see a picture of it there. I've also got one live with us here. So one side's linear, one side is circular. And you mount it basically with magnets to the front of the light, depending on what you want. So there's also two polarizing filters that go on the front of the lenses that allow you to do the linear polarizing. But it's very fast, especially the circular. You just place the lenses or the filters on the lenses, place the circular polarizer front facing out, and you're polarized. It's that simple, which is really nice. The linear polarizer, obviously, you have to rotate the filters to basically get the effect the same way. But there's a lot of pros and cons for this new system. So the reason to polarize, obviously, typically with polarizers, right, we like to control the intensity of the unpolarized light reaching the camera sensor. So this allows us to reduce glare and noise on our regions of interest. In the past, you could have on our ARAMIS systems, there was the linear polarizers that you could mount. Those are typically best at reducing glare from both kind of smooth or metallic surfaces. The circular polarizers, which we haven't been able to use before, are kind of better for more optically complex setups. So talking about maybe we're looking through glass, for instance, so through like different lenses, mirrors, or like beam splitters with our lights. Think about like thermal chambers with glass optical windows. So it's a really great tool for that. The The linear polarizers, obviously, we still have that option with this new system too. So it provides typically higher light transmission with less heat buildup. But it is sensitive to the angle of the camera and the lights themselves and the orientation. So if you weren't correctly optimized for your orientations, you'd have to redo the polarization to make it more effective. With the circular, there's less alignment needed. You're basically just mounting it and ready to go. Works in any geometry. It does absorb more light though, so it is a darker image. So you may need to adjust your exposure time more or open your apertures potentially to get a little bit more light in there if you don't have enough. But the really nice thing about this light is that it's 45 megawatts, or excuse me, not megawatts, 45 watts lighting system compared to our original on the ARAMIS system is only a 10-watt total with the dual LEDs. So almost 4 times as much light you're getting with this singular LED on the new system, which is really powerful. So using the circular polarizer shouldn't really have any dramatic effect now on between the two systems there. You also have some different swappable options. So we have diffusing filters that you can place on the front. So it comes standard at 15 degrees, but you can apply a filter for 25 and 45 degrees, or 25 and 40, change that, as options there. Whereas with the old dual LED systems, they were all fixed. So they're usually 30-degree light system. You couldn't really change that. So we can really zoom in on an object if you're looking at a small field of view. You don't want to diffuse your light everywhere. You want your lights all on your samples. So we could have no diffusers on and be really zoomed in on that object. Or if you have a larger field of view, you can basically distribute the light more across the entire surface there. Again, it's really fast, easy to use. If you look back at the picture of that system, basically it's mounted right on top. You can control it both from the back of the light or in the software. You can turn it off and on. So really good features with that system there.
Right. So some of the other questions we got is screen output voltage from the software possible to have an input to the load frame for a strain controlled cyclical test?
Yes. So you can output different inspections from the software as analog outputs. You just have to configure them when you're doing this setup there. So I'd recommend we can set up a time. Just contact one of your further reps, and we can have a discussion about how to do that in software.
And then, so this is a great question from Simon Lee. So, as far as does the sensor require calibration, and if so, how often does it require?
Yes. So your original setup, when you first configure the lenses for your field of view, your volume you choose, you do need to run a calibration routine. So they have, like Walter mentioned in the video, there's 2 calibration objects with this system in particular. Yeah, you basically need to be able to run the calibration the first time. Once you get a good calibration with that, there are tools kind of built in the software that we look at to determine if we're still in calibration. One of those mainly is the intersection deviation. And we're tracking that kind of as we go over time. So as we notice that deviation start to increase, we typically like to redo our calibrations to get that back down. There are some other tools software we can talk about at future time as well that have enabled us to be able to kind of help adjust calibrations without having to do a full routine. I do recommend kind of reaching out to us for kind of a more in-depth discussion on that.
Let's see. Can you clarify why we don't need to worry about light intensity when using polarization with the ARAMIS 1?
Yeah, it's mainly just because of the power of the lights. So instead of being 10-watt lights as we had in the past, so you'd have to be a little bit more cognizant with the filtering you apply. So if you apply polarizing filters to the 10 watts, your image would get pretty dark. So you'd have to either be pretty close to your sample with the lights to keep the intensity you want, or you have to open your apertures or run into slower exposure time. So with this, since we're pretty much almost 4 times as bright, we don't have to worry as much about the polarizing options because of just the fact that, if we kill the amount of light, we still have enough with polarization to see our image at a good exposure time. So it's kind of a nice tool with this. And we can also, you can add more of these lights as well. So kind of similar to the older systems, you can have magic arms with multiple of these lights. We circular polarize everything. You can have 90 watts basically of light on your sample. That should be pretty good too. So, a great question.
Awesome. And then they've got another really good one from Kurt Horton. Does the ARAMIS controller have an event output to sync with traditional data acquisition systems?
Event output. So yeah, basically the ARAMIS controller by default will output either a 5-volt or 24-volt TTL signal every time you take an image. So if you want to trigger something off of that full signal, basically we can do that. There's a couple other options, but mainly that would be the one.
And then I got another question. Anonymous says the pricing that I mentioned earlier does include a software license. Is circular polarization really useful for everyday tests, or is it only really for special cases?
It's a good question. I think it's definitely more effective on special cases, but if you do notice, like it will reduce noise on the surrounding area as well. So it can also be just effective to use that in general. Obviously, most of the polarizers are filters. They're just laminates on these materials. So if you use them a lot or very often, eventually you will burn through. So sometimes I like to be a little bit more choosy with when I use them, but in general, especially with the intensity of light we have now, you're not really going to have any negative effects of using the polarizers. It's mostly positive outcomes from that from using those. Let's see.
Where was it? Oh, sorry. This is a question related to applications. Looks like, can we use DSE to capture plastic coupon strain in an Instron environmental chamber? So, an environmental chamber, like, yeah, I would assume that would mean, yeah, you'd need as long as it's more of like the window I think is more of the biggest concern there, and like what we can actually see in the chamber.
Yeah, so it just depends on the viewing window, the optical window basically you have of the chamber. But yes, we can definitely capture displacements and strains inside chambers. We have one at our office, the Seattle office. But yeah, we've done multiple different tests, mostly for CT analysis, but we can also do just normal, like if you have a large enough chamber, you could do a full tensile test, things like that. So we can definitely do that, especially with the polarization options here. It's going to be a lot better. In terms of like reflections from the glass, clarity, and things like that. But yeah, it's definitely do.
Can you speak to the optical clarity aspect? I think a lot of our customers probably do have applications where they are measuring through, shields and glass. Can you speak to that?
Yeah, so I mean, the kind of main idea is like obviously we want to hinder. What's sentence? But it's basically we don't want to hinder any of our optical paths in terms of what we're seeing on the image. So avoiding diffraction, reflections, refractions, things like that can affect the image quality of your object of interest is pretty important. So usually with like thermal chambers, we're using optically clear glass, so that way there's no distortions being added to the image, no diffractions, things like that. We try to avoid like multi-laminate layered plexis and things like that, because those will also cause distortions on the image. And we usually try to avoid thinner plexiglass as well. So if you're using like Lexan or whatever, it's about a 1/4 inch or so. It's probably a good amount when doing that. Just so it's thinking out that it doesn't warp or anything while it's being placed. You can't physically warp it yourself that easily. So we just want to be kind of as stable as possible. We can also calibrate if you do have something like that. You can try to calibrate the system through the plexiglass, as long as you keep all the orientation the same afterwards at the same location on the glass. You could still calibrate through it and kind of take account of those distortions with the calibration file. But I always recommend just kind of getting the best optically clear material that you can get.
Yeah, I think we encountered that a lot. Like not just like it's when you are having a test where there might be potentially flying debris or things that could potentially damage the cameras. In some tests where you have like a COPV burst or a pressure vessel burst, there's water. We've seen quite a lot in the testing with in Trillion. So yeah, just something to consider. And so let's see, we covered this question so far. So as far as and we talked a little bit about this, so can you talk about the adjustable camera bar and, what is some of the benefits of doing that in a lab space and, how is that contrasted between some of the other types of sensors that ZEISS offers?
Yeah, so I'll say the 5M system is, or excuse me, the ARAMIS one, the 5M cams. Comes with the shorter bar option, so it's only a 500 millimeter bar instead of the 800 millimeter. So that off the bat already kind of gives you a little bit more flexibility in terms of positioning, where you can kind of manage space needed for the system here. The adjustable system again gives you the flexibility to choose different volumes depending on what your test size is. We typically like to optimize our tests where the area of interest on your sample is kind of filling the field of view as much as possible. So kind of almost zoomed in as much as possible on that area of interest. And that's where the kind of adjustable base really shines, being able to optimize that, especially with the ARAMIS 1, anywhere between 50 to 500 millimeter areas of interest. It's kind of what we can look at there. And then if you're going to use, and then the other kind of end of the spectrum, if you're more interested in maybe doing the same test every single day, it's a 50 millimeter dogwood sample every single day. They do have fixed base systems where the bar that you adjust the cameras on is basically fixed distance so that the cameras can't move on that bar. So there's less adjustment options. It's more rigid. So it holds calibration a little bit longer, but it's limited to that kind of singular field of view. So you're kind of just always doing that same thing.
Yes, the adjustability is not
so for test labs, maybe more dynamic stuff where you're doing coupons one day, full components another, larger small areas, having an adjustable base system is pretty critical for those in terms of the flexibility that it offers. With the drawback being that you need to pay a little bit more attention to your calibration and how much you kind of move the system and things like that.
Okay, let's see. Can the two cameras be used independently for 2D measurements? Yes, they can. That's definitely something we will, that's probably something we're going to get into a little bit more tomorrow in the training. But yeah, that is a capability of the ARAMIS sensor. I have this one here. I really want to learn how to use the machine and learn the software. Are there any materials to learn or any series of videos? Well, I'm sitting next to the author of some really outstanding training videos. I'm sorry, I'll let you talk about that. But
no, yeah, definitely. So we do have some free free training materials available online. I definitely recommend we use trillion.com/FAQ. It's kind of our newer FAQ site where we discuss a lot of these different questions. We also have a YouTube page. We have a kind of full series right now on analysis, both 2D and 3D, and it's all free to look at. So, but we are updating those as we go over time. So we also have currently a Spanish version available as well. So if you'd like to view those, it's really translated up on the site, which is pretty cool. And then we are working on some newer 2025 and potentially also some acquisition videos where we go through setup, calibration, doing the focus, the apertures, things like that, and the lenses. So that can be eventually that'll probably be available. But yeah, so we're always adding to those, especially the FAQ site. So if you'd like to look at some more of that information, we can also provide you some more links to free trainings or even paid trainings from ZEISS if you're interested in those as well.
Yeah. We're very big on the education side. So definitely don't hesitate to reach out. Do you guys, for those that attended do you guys have any questions or anything that we haven't covered so far in the discussion? Let's see. Do we have any others from the audience? We answered most of these. Yeah, there's quite a few. All right. Well, I think that we'll call that a wrap. Want to say thank you again to everybody who was able to make it. And yeah, if you have any questions about anything that we've covered in the webinar today, don't hesitate to reach out to us.